Now, today I will proceed the remaining reduction formulas for n trigonometric functions, which is secant inverse of z with respect to x, or secant power n of x with respect to x. X is a simple variable, and z, maybe we are confused. So what is reduction formula? So reduction formula is often used in integration for working out integral of higher order. It is an integral of higher order, which is n, and we don't know what is the value of n. It is lengthy and tedious to work across higher degree expressions. So for that, we can derive the reduction formula for this function. So, and here the reduction formulas are given as simple expression with a degree n to solve these higher degree expressions. These reduction formulas have been derived from the basic formulas, which is either Pythagorean formulas, Pythagorean identities of trigonometry, which is 1 plus tangent square of x equal to secant square of x. 1 plus cotangent square of x is cosecant square of x. So we will work on this formula. So the first is secant of n of x dx. We know we can write secant n of x is secant power n minus 2 of x with secant of x, because secant power n of x is equal to these two functions. So what is basically the reduction formula? The following reduction formula are helpful to work across higher degree expressions involving algebraic variables. This formula involving algebraic variables, trigonometry functions, logarithmic functions. The reduction formulas have been presented as below is a set of 4 formulas that I have been derived in the previous lecture. So integral of secant of n of x with respect to x is equal to integral of secant power n minus 2 of x dx with secant of x dx. This is first function and this is second function. This is first function, this is second function, and this function is in product, so we can apply the integration by parts rule on these two function. It is secant square of x, sorry, it is secant square of x. I mistakenly write the secant of x because secant n minus 2 of x with secant of x is equal to secant power n minus 1 of x, which is not equal to secant of n of x. That's why it is equal to secant square of x. So apply the integration by parts rule. So this is first function, this is second function. So first function, integration by parts using integration by parts. So this is first function n minus 2 of x. First function integral of second function. So first function integral of second function, integral of secant square of x with respect to x minus whole integral of derivative of first function, which is secant of n minus 2 of x dx, and integral of second function, which is secant of secant square of x. This is the integration by parts formula that I have applied on these two functions. So now simplify this formula, and this side is equal to integral of secant power n of x dx. So first function integral of second function. So first function in its place secant of n minus 2 of x, integral of second functions. So integral of secant square of x dx is tangent of x, tangent of x, because derivative of tangent x is equal to secant square of x. So derivative integration are the reverse of each other. So integral of secant inverse of x is tangent of x. So integral of secant square of x is tangent of x. So first function integral of second function minus whole integral of derivative of this function. So derivative is very easy, n minus 2 secant of n minus 3 of x, and again derivative of secant x, which is secant x tangent x, and integral of secant square of x is tangent of x, which is multiply with this tangent of x, it's become tangent square of x with respect to x. So secant of n minus 2 of x and tangent of x minus, so it is equal to n minus 2 basis same power will be added of this secant x and secant x, which is secant of n minus 2 of x with the tangent square of x, and we know that tangent square of x is equal to secant square of x minus 1. This is Pythagorean identity, which is secant square of x minus 1 with respect to x. Now this side, let this side is equal to I n. So first function in its place secant of n minus 2 of x with the tangent of x minus n minus 2 will be common from these two functions. It is equal to integral of secant of n minus 2 multiply this function to this and this minus 1, so it is equal to secant of x and multiply with this minus 1, so it is secant of n minus 2 of x with respect to x. So this side is equal to in, so it is equal to secant of n minus 2 of x tangent of x minus n minus 2 in its place, and these two functions, this function is subtracted from these functions. Now apply the n minus 2 with this function and with this function, so it is secant of n of x with respect to x, and n minus 2 multiply with this function, so minus with this minus is plus, so it is n minus 2 and integral of secant of n minus 2 of x with respect to x. Now this function is equal to in. This function is equal to in. Integral of secant power n of x dx is equal to in. So in is equal to secant of n minus 2 of x tangent of x minus n minus 2, and in plus n minus 2. If this is in, then it is, let's suppose it is in minus 2, so shift this function to this side, so in plus n minus 2 of in is equal to secant of n minus 2 of x tangent of x plus n minus 2 with in minus 2. So in is common in these two functions, so 1 plus n minus 2 is equal to secant of n minus 2 of x tangent of x plus n minus 2 and in minus 2. So 1 plus n minus 2 is equal to in is equal to 1 plus 1 minus 2 is equal to minus 1, so it is n minus 1 is equal to secant of n minus 2 of x with tangent of x plus n minus 2 into in minus 2, so dividing n minus 1 on both sides. So this is the reduction formula for integral of secant of n of x, which is equal to secant of n minus 2 of x with tangent of x divided by n minus 1, here is n minus 1, plus n minus 2 divided by n minus 1 n minus 2. This is the reduced formula for integral of secant of n of x. So in short, we can find the integral of any functions which is of high power. For example, if someone gives us a question which is secant power 10 of x dx, we cannot directly find its integral, but here with the help of this reduction formula we can find its integral. So secant power 10 of x, we will compare these two formulas. and will find its integral. So if you like this video, please share it with your friends, and if you have any question regarding this lecture, then you can ask me in the comment section. So thank you.